So hi everyone, welcome back to yet another video with Moments of Chemistry. And today we are going to discuss from question number 21 to question number 30 in the 2019 new syllabus chemistry MCQ paper. Okay, question number 21. A buffer solution of pH 5 was prepared by mixing equal volumes of 0.1 mole per cubic decimeter monobasic weak acid solution and a 0.1 mole per cubic decimeter solution of the sodium salt of this acid. The pH of the resultant solution when 20 cubic centimeter of this buffer solution was mixed with 90 cubic centimeter of 1 mole per cubic decimeter of the weak acid solution. Okay. Now it's a monobasic weak acid. Just take an example, CH3, COOH. Example that we are more familiar to. So CH3, COOH aqueous reversibly dissociates to give you CH3, COO minus aqueous plus H plus aqueous concentration. Okay. The sodium salt CH3 COONA aqueous completely dissociates to give you CH3 COO minus aqueous plus Na plus aqueous. So, if the sodium salt is 0.1 mole per cubic decimeter, this acetate ion is also 0.1. So, initial acetate is 0.1 plus 6. 0.1 plus 6. Okay. H plus aqueous concentration, pH 5. pH 5 means H plus aqueous concentration is 1 into 10 to the power minus 5. You don't have to even write that. So this is 1 into 10 to the power minus 5 plus 6. If I consider the initial concentration to be M minus X. So X is negligible compared to all other parameters. So Ka equal to CH3 COO minus aqueous concentration into H plus aqueous concentration divided by CH3 COOH aqueous concentration. Okay. So here Ka equal to 0.1 into 1 into 10 to the power minus 5. So that is 1 into 10 to the power minus 6 divided by M. Equation number 1. Look at the next situation. The pH of the resultant solution when 20 cubic centimeter of this buffer solution was mixed with 90 cubic centimeters of 0.1 mole per cubic decimeter of the weak acid solution. Okay. Now we need to find the H plus aqueous concentration when CH3 COO minus aqueous concentration is not known. So in the new situation, this is Y, this is Y. Ka equal to Y squared over new concentration of acid 0.1 is there in 1000. How much is there in 90? If this particular value is there in 110, because the total volume will be 20 plus 90. 110. How much is there in 1000? 0.9 over 11. 0.9 over 11. So Ka equal to 11y squared over 0.9. So both the Ka's can be made equal. But here we don't know M and we don't know Y. We have to construct an equation to determine both Y and M. So for that you can do something like this. Look at this. Buffer solution of pH 5 was prepared by mixing equal volumes of 0.1 mole per cubic decimeter weak acid solution and 0.1 cubic decimeter solution of sodium salt of this acid. Okay. The new concentration is half of this. Why? Because this was for V, but for 2V it's half. But so this is 4 here. So this will be 4. We don't know the initial concentration of CH3 COOH. No, we know 0.1. This is also 0.1. This is also 0.1 minus 6. So initial concentration is also 4 into 0.1. 4 into 0.1. Okay. So pH of the resultant solution when 20 cubic centimeter of this buffer solution was mixed with 90 cubic centimeter of 0.1 mole per cubic decimeter of weak acid solution. Okay. So this particular acid solution, this is the acid we have. We are going to mix it with another weak acid of 0.1 mole per cubic decimeter and this buffer. What does this buffer have? This buffer has CH3COOH. This buffer has CH3COO minus. This buffer has H plus. So if I consider it as y squared, for the new equilibrium is like this. Look at this. CH3 COOH aqueous giving you CH3 COO minus aqueous plus H plus aqueous. So in the new solution, the new whatever the mixture we have, now this was the initial one, that's done and dusted. Finished. Here, we don't know this, but we know that 0.1 mole per cubic decimeter of the weak acid solution. So now the total weak acid solution within our mixture, total new CH3COOH aqueous concentration, how can you find? We have 0.1 over 1000 into, from this we are taking 20 cubic centimeters. From this is the number of moles of COOH that came from the initial solution. COOH that came from the initial solution. Plus. Now the new solution that we are introducing. New introduced solution. That is 0.190. So 0.1 over 1000 into 90. Total volume 110,000. This is the new CH3COOH aqueous concentration. H plus aqueous concentration is not known. I consider that one to be Y. That's what we are supposed to find. Y. CH3COO minus aqueous concentration. That is from this same CH3COO minus will come. So that is 0.1 over 2. If that was there in 20, total is 110. How much is there? 1000. So for this, if I write the Ka expression, look carefully. Ka equal to Y into this one. This one is how much? Look at this. I can do simplification very easily. This is 10. So 1 over 110 into 1 over 110, down what will come? This particular expression. Look at this. All these are cancelled. So this is 2 plus 9. And look at this. Look at this. 2 plus 9, 11. 2 plus 9, 11. Y into 1 into 110. So this is Y over 11. So if I equate these two, Y over 11 equal to, here, 1 into 10 to the power minus 6 divided by 0.4. 1 into 10 to the power minus 6, 0.4. So this is 4 into 10 to the power minus 1. 4 into 10 to the power minus 1. Look, I am going to try to take a very close answer. 4 into 10 to the power minus 1. So this one will be 11 over 4 into 10 to the power minus 7. So roughly 2 10 to the power minus 7 again, roughly 6. But you know that due to common ion effect from this CH3COO minus, the equation now this CH3COO minus that comes here is utilized for this equilibrium. So therefore more and more forward shift. more and more forward shift, H plus aqueous concentration increases, pH decreases. So therefore a value that is substantially lower than 6, it can't be 6. Substantially lower than 6, the best answer you can go for is 4. So your pH should be 4. Question number 21, answer is answer number 2. Actually you had to do all this calculation just to come to a wild guess like this. Now pH 5, no, we'll think like that. Now this is the formal way of doing it. Initially pH 5, no, we are putting more CH3COOH. If we are putting more CH3COOH, forward reaction favored. H plus aqueous concentration increases, pH decreases. So your pH should be surely less than 5. So 1, 2, 3 possible. It can't be 4.5 due to subtle amount. It should be a substantial amount. So second one is your answer. For question number 21, your answer is 2, 4. Answer is the second one, pH 4. Okay. Question number 22. Consider the following 3 aqueous solutions: weak acid, equimolar mixture of weak acid and sodium salt, titration mixture at the equivalence point of the titration of the weak acid and strong base. When each of the solution is diluted by the same amount at constant temperature, the pH. Okay, weak acid. Now weak acid is something like this, no? If we dilute, we put more and more water. We put more and more water. If we put more and more water, the concentration of the weak acid decreases. Concentration of weak acid decreases means the equilibrium is shifted more towards the left. So therefore H plus aqueous concentration will have to reduce. If the H plus aqueous concentration reduces, pH increases. So your first one answer should be pH increases. 21, the first one should be increases. Next one, equimolar mixture of weak acid and sodium salt. If we put weak acid and the sodium salt, it's something like this, no? Equimolar mixture. So his concentration is also the same, his concentration is also the same. If we dilute it, both these components change by the same factor. From the Ka expression, both these components change by the same factor. So therefore, if you dilute it, no change is going to happen to the equilibrium. Next one, titration mixture at equivalence point of the titration of the weak acid and strong base. Weak acid, strong base. We don't have acid, we don't have base, but we have a basic salt. We have a basic salt. So it's something like this: CH3 COO minus giving you CH3 COOH and OH minus. So if you dilute it, his concentration will have to decrease. Volume increase, concentration decrease. So therefore this equilibrium is shifted towards the left according to each Achilles. OH minus aqueous concentration decreases, which means pH decreases. pH decreases. So your answer for question number 22 will be the second one. First, what happened for the weak acid? This is the weak acid. We diluted it. You diluted it. So therefore the concentration increases. If the concentration increases, what will happen? Forward reaction favored. H plus aqueous concentration increases. Sorry, H plus aqueous concentration decreases. Why? See, the equilibrium shifted towards the left. Sorry, the backward reaction is favored. So therefore H plus aqueous concentration will have to decrease, pH will increase. Here pH will decrease, in the middle one it will no change. So for question number 22, your answer is answer number 2. 23. Incorrect statement regarding the oxoacid of chlorine, HOCl, HClO2, HClO3, HClO4. The shades around chlorine in HClO2, HClO3, HClO4 respectively. Okay. We'll draw the structures first of all. Then it will be more easy. HClO2. HClO2. Angular. Next one. HOCl. I forgot that. HOCl. This is HClO2. This is HOCl. HOCl is what? Angular. This is HClO4. HClO2. Okay, then HClO3. This one. This is trigonal pyramidal. Final one, HClO4. HClO4. That is tetrahedral. So HClO2 is angular, HClO3 is pyramidal, trigonal pyramidal, and HClO4 is tetrahedral, correct? Oxidation states of chlorine in HOCl, HClO2, HClO3 and HClO4 respectively are +1, +3, +5, +7, that is correct. Next one, acid strength varies. Highest is for HClO4, why? Higher the oxidation state, higher the acidity. So HClO4 is +7. Higher oxidation state, more pulling. So more electronegativity. And apart from that, they will have higher acidity also. So third one is correct. All these oxo acid contains at least one double bond. No, HOCl has the double bond. No double bond. So fourth one is wrong. All these oxo acid contain at least one OH group. Here we have an OH, here we have an OH, here we have an OH, here we have an OH. So your wrong one is the fourth one. At least one double bond, it doesn't validate for HOCl. So your answer for question number 23 is the fourth one. Question number 24. Density of an aqueous acidic solution is 1 kilogram per cubic decimeter. pH of the solution is 1. Its H plus aqueous concentration in ppm. Okay. pH 1 means, what's the meaning of it? pH 1 කියලා කියන්නේ 24. pH 1 means H plus aqueous concentration will be equal to 1 into 10 to the power minus 1 mole per cubic decimeter. But density of the solution is 10 kilogram per cubic decimeter means, sorry, 1 into 10 to the power 3 gram per cubic decimeter. Gram per cubic decimeter. So this will be, this is the total mass. The mass gram, if I can convert this to gram per cubic meter, 1 into 10 to the power minus 1 gram per cubic decimeter. So then the ppm value is going to be his mass 1 into 10 to the power minus 1 gram per cubic decimeter divided by the total one 1 into 10 to the power 3 gram per cubic decimeter into 10 to the power 6. So this is here 10 to the power 3, so 10 to the power 2 is your answer. That is 100. So your answer for question number 24 is the third one, 100. Okay, so what is ppm? ppm is the mass fraction of a particular component in a solution into 10 to the power 6. That's simple. Okay. So then for question number 24, your answer will be the third one, 100. 25 gram sample of polluted air containing ozone is treated with an acidic solution of excess Ki. Ozone is converted to O2 and water during this reaction. The iodine liberated is titrated with 0.002 mole per cubic decimeter sodium thiosulfate solution. Volume of Na2SO3 required was 25 cubic centimeters. The percentage of O3 in the air sample. First of all, write down the equation for 25. 25 O3 converted to O2 in the presence of an acidic medium. So here 3 oxygen, 2 oxygen. So 1 oxygen should come from water. So here H2O plus 2H plus 2 electrons. That is the reduction reaction. Oxidation reaction 2I minus I2 plus 2 electrons. So O3 is to I2, 1:1 ratio. Easy. Then I2 is to S2O3 2 minus is this. So number of moles of S2O3 2 minus utilized is 0.002 is there in 1000. 0.002 is there in 1000. How much is there in 25? How much is there in 25? So number of moles of I2 liberated, 0.002 divided by 1000 into 25. If this is there in 2, how much is there in 1? 0.001 over 1000 into 25. So number of moles of O3 present is also the same one, 0.001 divided by 1000 into 25. Number of moles of O3 present, 1:1 ratio from this equation. Then mass of O3, 0.001 over 1000 into 25 into 16 into 3. So then question is asking us percentage mass of O3. Percentage mass of O3 equal to 0.001 divided by 1000 into 25 into 16 into 3. Total is 25, so 100. Total mass is 25. Then 25 is the total mass. Then you have to convert it to percentage. You have to multiply by 100. So 25 cancels. 1, 2 cancels. So here 10 to the power minus 4 into 48. 48 into 10 to the power minus 4. That is 4.8 into 10 to the power minus 3. So your answer for question number 25 is the first one. 48 into 10 to the power minus 4. That is 4.8 into 10 to the power minus 3. First one. 25 answer is answer number 1. 26. The following reaction steps, which of the following reaction steps is not present in the Born-Haber cycle of NaCl solid formation? We will draw the Born-Haber cycle, will you, first of all? So this is okay now. Answer is 48 10 to the power minus 4. We will draw the Born-Haber cycle. Now, to show this question, I am not going to draw the enthalpy level diagram. I am going to stick up with the thermocycle. But if you are answering the essay questions, you can't restrict yourself to thermocycles. Always, it's better to use the enthalpy level diagram. Okay. So here, Na solid plus Cl2 gas giving you NaCl solid. So this is delta H theta formation. So this is half. Then Na gas, then Na plus gas. Then this will be Cl gas, then this will be Cl minus gas. So this will be Cl minus gas. So these two together will give you this. This is lattice enthalpy delta H theta L. This is delta H theta sublimation. This is delta H theta IE1. The first ionization energy. This is delta H theta bond dissociation enthalpy. This is delta H theta EA, electron gain enthalpy, EG. Then lattice. So here the one that is not involved in this particular cycle is Na plus A equals Cl minus A equals Na plus A equals. There's nothing like that, no. We have only Na plus gas, Cl gas, NaCl solid. So the first one, at a glance you can take that one as the answer. So 26, your answer is the answer number 1. Okay. 27, activation energy of an elementary reaction A gas plus B gas giving C gas is Ea. This reaction is catalyzed by metal N. So there is a metal that catalyzes the reaction. It provides an alternative pathway with different activation energy. Then energy diagram of the catalyzed reaction is given. So look at this. So this is the reaction coordinate. Reaction coordinate. This is the energy, or specifically speaking the potential energy. Then okay. So this is E1. These are the given data. A gas Class B gas. Then this is the so this is E3. This is C gas. Then this is delta H theta 1. Okay. Now we have to see what the activation energy of this particular reaction is. What is activation energy? You start from this and go to the maximum point. This is the activation energy of the reaction. The energy difference between the reactant and the highest possible activated state. This is EA1. This EA1, it is like E1, this is E2, this is E2. If you properly speak, it is E1 plus E2. Sorry, if you are to properly speak, it's delta H plus E2, but not correctly delta H plus E2. It should be a bit greater than delta H plus E2. Why? Look at this. If I take this is delta H, this is E2. But delta H plus E2, a bit greater than that particular value is this EA. This is EA. Activation energy for the reaction is from this point, you go to the maximum possible point. This is the activation energy of the reactant. It is the activation energy of the slowest step. Delta H theta 1 is from this trough to this point. E2 is from this to this trough. But our EA, the reaction should be greater than that, no? It should be greater than E1 and E2. This gap is greater than this gap plus this gap. So your answer for question number 27 is the fifth one. 28. For a given acid, it can be given that F equal to amount of acid dissociated divided by the amount of acid undissociated. Amount of acid dissociated divided by the amount of acid dissociated. Which of the following graph give the relationship between log F and pH? Log F and pH. Okay. If you consider any acid, let's say for example, HA is our acid for 28. Imagine HA is the acid. HA aqueous giving you H plus aqueous plus A minus aqueous. So then Ka equal to amount undissociated. Undissociated acid amount. Undissociated acid amount. Down. Up. H plus aqueous into A minus. What is A minus aqueous? It is equal to the amount dissociated. Dissociated amount is equal to the amount of A minus aqueous that is formed. Amount of acid dissociated is equal to the amount of A minus aqueous concentration that is formed. So here we need to subject H plus. So H plus aqueous concentration equal to Ka into undissociated over dissociated. Undissociated over dissociated means 1 over F. So here if I take this one as pH, minus log Ka is pKa minus log 1 over F. Minus log 1 over F. But we need it for log F. We need it for log F. So since we need it for log F, I am going to rearrange this equation like this. F equal to Ka over H plus aqueous concentration. So if I take minus log everywhere, minus log F equal to minus log Ka minus log H plus aqueous concentration. So minus log F equal to minus log Ka. This is pH, minus pH. So if I multiply the entire equation by minus 1, log F equal to log Ka plus, log F equal to log Ka, this is plus no, minus plus no. So this will be minus pH. minus log F equal to minus log Ka. Look at this one again. Minus log F equal to minus log Ka minus log Ka minus log H plus. So minus log H plus is pH, minus log Ka minus log F. So minus log Ka is pKa. Minus log F equal to pKa. So here minus pH. So log F equal to, this is pK, okay? So log F equal to plus pH minus pKa. So y equal to plus 1 will be the gradient, mx minus c graph. Y equal to mx minus c graph. Fifth one is the answer. Y equal to mx minus c. So you should have a positive gradient and a negative y-intercept. Answer is the 28. For 28, answer is the fifth one. 28 answer is fifth one. This is just like a physics proof. You rearrange whatever you know to get y equals something. So your answer will be the fifth one. Okay. 29. Which of the following statement regarding polymers is correct? Nylon is an addition polymer. Wrong. Nylon is a condensation polymer that is formed by dicarboxylic acid and diamine units. First one is wrong. Teflon is a condensation polymer. Wrong, no. Teflon is an addition polymer. C2F4. Bakelite is a linear polymer. No, it's a three-dimensional polymer. The number of carbon atoms in the repeating unit of natural rubber is 4. Is it 4? Is it 4? What is the monomer of natural rubber? Isoprene. So isoprene means there are 4 carbon atoms. So in an isoprene molecule, there are 4 carbon atoms. Isoprene molecule has 4 carbon atoms like this. First and last carbon have double bonds, and third carbon will have a CH3. So you will have 5 carbon in the repeating unit. Why the CH3 carbon? So that's wrong. Small covalent molecules are eliminated when monomers combine to form condensation polymers. That's correct. Ammonia, water, HCl, small molecules like this will get eliminated during the formation of condensation polymer. That's correct. 29, your answer is answer number 5. 29, answer is answer number 5. 30. Two ideal gases that do not react with each other are separated by a valve and kept in a rigid container. Okay, so they are kept in a rigid container. So you have, let's say, two ideal gases like this. They are kept in this particular rigid container. The system is maintained at constant temperature and pressure. Which following correctly describes the change in Gibbs energy, enthalpy, entropy of the system when the valve is open? Okay. Since they do not react with one another, will there be a net exchange of energy between the both? No. So delta H or the enthalpy change is 0. Why? There is no reaction. They are ideal gases which do not react with one another. So therefore, when we open them, let's say he is a good person. Okay. And he is also there. So when you open the tap, both of them come together, but they do not react. There is no reaction. So therefore, delta H is 0. Why? No reaction. No net exchange of energy from one component to another. So therefore, delta H is 0. What happens to delta S? Number of gaseous molecules increases. Randomness increases. So therefore, delta S positive increases. So if you consider the equation, delta G equal to delta H minus T delta S. So since this is positive, this is 0. delta G to make the equation validate the equation. If this is plus, minus T delta S is negative. So this is 0. So it's 0 minus some value. So this will be minus. So delta G is negative. So delta G should decrease, delta H should remain unchanged, and delta S should increase. So your answer for question number 30 is the third one. Decrease, unchanged, increase. We have two gases. Do not react. Open. What happens to these three components? Okay. So that marks the end of yet another video with Moments of Chemistry. And in today's video, we had discussed from question number 21 to question number 30. And thank you for watching, and hope this has added some amount of extravagance to what you study. Stay safe and don't forget to be with us in our journey of success. Thank you. Hey everyone, I think that particular video had added some amount of advantage to your pinnacle of success. Chemistry will indeed become one of your most favorite subjects at the end of what we take as a journey. So don't forget to like, share and subscribe this particular channel with those whom you like. And wait, whether your comments are advantageous or disadvantageous, please do put them down in the chat box, because everything amounts to us. So thank you and have a nice day.